Hello everyone, this is Dr. Harun Adar from Shanghai, China. In this tutorial, I am going to work with drought data using Python again. In my previous videos, I calculated different indices, uh, like the 4 key indices and SPI, D percentage, PNPI and RAI. So in this video I will try to visualize the data on decade wise and also maybe on year wise. So how to visualize or how to categorize that drought? Like we have the percentage values, but how will we know that in which place the data is it's drought or in which place there is no drought? So today I'm going to discuss how can we plot this data for each decade or maybe each year and different ranges of the years. So let's begin by importing the libraries. Here I'm going to use the GeoPandas library, which is actually to handle the geographic data. The pandas library for manipulating the data, and numpy is we previously used this one for numerical operators, and the matplotlib is for plotting the data. However, we can see here I am using different shapefiles for different regions. Like for the Bharatpur, I am using the shapefile of Bharatpur.shape, and similarly in the corresponding I am using the indices Excel file. Like this indices file I can show you here. This is the, for example, the Bharatpur indices file. It has multiple columns. The first column is the year and the next one is the annual precipitation. However, the next one is D percentage of winter, similarly D percentage of pre-monsoon and D percentage of the other seasons, and also the D percentage of annual. Similarly, we have SPIs and this SPI D percentage, SPI winter, SPI monsoon and SPI for all season, and similarly we have RAI data for each season, and in the end we have PNPI data for all seasons. But in this video we are going to handle D percentage values only. Maybe in the next video we will try to plot SPI. So the D percentage value, you need to plot the annual droughts and also the seasonal droughts. So let's begin how we need to handle this data in our Python. So going back to Python, so here we can see the shape files and also the corresponding Excel data files we have uploaded in this way. Next, to categorize the data for D percentage from the literature, we have found that if the values are greater than 20, it means there is no drought, and if it's less than -60, it means there is extreme drought. So after describing these categories, we have to also give the different colors to those categories. We create here the categorize drought function, where we can give the color of a red to severe drought, and we can use some other colors which can be easily distinguishable. We are using here blue for no drought. That's also quite logical. However, in the next to process each region and combine the result, we have open a data frame which can store all the data, like all data, and then we have use the load the Excel data and their sheet name for each station, and then we have converted this data to the this type of function. Like it can convert, like it will convert 1901 to 1900. Also it can convert the first decade all the values to 1900. So it can, this is a function to convert the yearly data to decade wise data. So after getting the decade wise data, we group the decades, each decade in separate groups. Like the first group is 1901 to 1910, and similarly the next ones. Also we have read the data from the percentage for season, and season we have columns in the Excel file: winter, pre-monsoon, monsoon, post-monsoon, and annual. So the real data column are the percentage dash winter, so it means the season can be replaced by winter and the others. Then we also here apply categories to this season, like if it's less than -60 it means severe drought, and if it's more than 40 then there is no drought. And the next one is we need to combine all district data together, and lately we have uploaded all the shapefile and merge our data with the shapefile. So like merging, it means like the district and the shapefile are merged with each other, like the corresponding shapefile. So next is we need to generate the maps. To generate the drought risk map for each decade, we create a matplotlib figure using plot.figure with a specific size. Then we define a grid layout using plot.gridspace to organize the map like in a three grids. So 3, it means 3 number of rows are 3 and 2 columns. So first row can hold the annual plot, and the second row can have 2 plots. Maybe it can be depend, like in this code, let me, yeah, it's the second row will contain winter and pre-monsoon, and the third row will contain monsoon and post-monsoon. So but here for the last we don't have data for all the year, just having the 3-year data. So to that's why we are going to start the year using if else function. If is the year starting from 2021, then we just need to start from 2021 to end at 2023. So then this is function for legends, like where to place the legend. Like I'm using 0.9, and it means it's on the very right side, and 0.98 it means on the very top side, so top right. So if font size is 20 and title size is also 22, so we can adjust this according to our needs. So then it will generate different file names, like if file number start here is 2021, then the file name is 2021 to 2023. The otherwise the file name will be start here to end here. So let's run this code and see how it display. I think it's all clear. If you need to run this code, you can ask the script in text. So let's run. So you can see here in the year of 1930 1940, this all the area is under mild drought, but we can see that in pre-monsoon this area is under moderate drought, but post-monsoon this is severe drought. However, in the monsoon season there was also very mild drought. Let's see, we can the last years, in the last 3 years there's no drought in the pre-monsoon, and there's no winter season also. This area, the bottom area, is showing no drought. So but in the annual map we can see there are some normal drought in the in some regions of this shapefiles. But this decade was, we can see the maps more in the detail, like it can be saved over here in drought maps here. So this is a map for 2010 to 2020, last decade. So here we can see the winter season is under mild drought, and there is no severe drought in severe drought is in post monsoon season in this region. So this is a beautiful way to plot our drought maps, like which district is under severe drought, which district is under mild drought. I hope this video is very useful for the students or the colleagues who are working on drought analysis um, or precipitation data analysis. If you really feel this is helpful for you, you can subscribe to my channel and like the video and share it to your friends. Thanks for watching. Have a good day.